For this lesson, we're going to look at how to solve a quadratic and polynomial equation by factoring. Here are some really general steps that you can follow each time you're asked to follow a quadratic or a polynomial equation. The first step is to set the equation equal to 0. The next step is that you're going to factor, followed by setting each factor, which will be either a monomial or a binomial, equal to 0. And lastly, you're going to solve each individual equation. Let's take a look at our first example. We have 2x squared equals 10x. So based on our directions, our first step is going to be to set the equation equal to 0. You'll notice that we have 10x on the right side of the equation. So I'm going to move that over to the left side by subtracting 10x. So now that my equation is equal to 0, my next step is going to be to factor my problem. You should notice that this problem has a greatest common factor. That's my factoring method. And my greatest common factor of this problem is 2x, which leaves me with x minus 5. That takes care of the second step in my problem. The third step says to set each factor equal to 0. The first factor that I have is the 2x. So one equation I'll write will say 2x equals 0. And for my second equation, I'm going to take x minus 5 and set that equal to 0. The reason I'm setting both equations equal to 0 is because my original problem we had set equal to 0 as well. For my final step, I will solve each equation. So in my first equation, I'll divide by 2 to get x equals 0. And in my second equation, I'll add 5 to get x equals 5. The two solutions to my problem are 0 and 5, written as a solution set, least to greatest. Something you should notice as you do these problems, the number of solutions you get is dependent on the degree of your polynomial. The degree is the highest exponent. So whatever the degree of your polynomial, in this case our degree was 2, that tells us that we'll have 2 solutions to our problem. Let's try another example. For our next example, we have x squared equals 2x plus 99. I'm going to start off by moving the terms on my right over to the left. So my equation is now x squared minus 2x minus 99 equals 0. Next, I'm going to solve. This problem is a trinomial with a coefficient of 1 in front of my x squared term. So I'm going to factor this into the product of two binomials, which will be x minus 11 times x plus 9. Next, I'm going to set each equation, each factor, equal to 0. So for my first solution, I get x equals 11, and my second solution is x equals negative 9. I'm going to write this as a solution set with my solutions from least to greatest. And again, we should notice the degree of this polynomial, the highest exponent was 2, and so I did get 2 solutions to my problem. Let's look at another. 2g squared plus 9g minus 5 equals 0. Notice that this problem is already set equal to 0 for us, so now we can get into our factoring. This problem does not have a greatest common factor, so we're going to be factoring as the product of two binomials when we have a coefficient in front of our leading term. This problem is going to factor into 2g minus 1 times g plus 5. Remember, if you're not sure about how I'm factoring these problems, you can always refer back to your notes from earlier in the chapter for our factoring methods. You may also check the two factors that you've got by foiling to work backwards to see if you get the original equation again. Now that I've factored, I'll set both terms, both factors equal to 0. And I'll begin solving. On my first equation, I'll add 1 to both sides and then divide by 2, so g equals 1/2. And in my second problem, I'm going to subtract 5, so g equals -5. The degree of my polynomial was 2 again, and my two solutions are -5 and 1/2. The next example that we have is an example of factoring a polynomial. This polynomial has 4 terms to it. If you remember from earlier in the chapter, any polynomial with 4 terms, we are going to factor by grouping. So I'll group together my first 2 and my last 2 terms. The greatest common factor for my first group is going to be x to the second power, leaving me with an x plus 4 in parentheses. For my second group, my greatest common factor is going to be a -3, leaving me with an x plus 4 in parentheses. To continue my factor by grouping, I'm going to write down the greatest common factor as a result of my 2 groups, which is x plus 4, followed by the leftovers from my factoring, which was x squared minus 3. Now that I've factored completely, I'll set each factor equal to 0. The solution to my first equation is that x equals -4. In my second equation, first I'll add 3 and take the square root of both sides. Don't forget that if you square root while you're solving a problem, you always have to include the positive and the negative solution. The degree of this polynomial was a 3. My 3 solutions are going to be -4, negative square root of 3, and positive square root of 3. In our final example, x squared equals 16, we have 2 ways that we can solve this problem. The first way, we'll stick with the steps that we've been using for this section, which are to set the equation equal to 0. Next, we can factor this by the difference of 2 squares, by the difference of perfect squares, which is going to be x plus 4 times x minus 4, which means that if I set each factor equal to 0, I will get x equals -4 and +4 for my solution. There is another way to solve this problem, which I'll show you in red. I'm just going to rewrite my original equation, x squared equals 16. Another method of solving this problem would be to take the square root of both sides, which will get rid of my x squared term, leaving me just with an x. The square root of 16 is 4, and don't forget that our degree here was a 2. We have to have 2 answers, so do not forget to include your plus and minus sign when you take the square root. So you will still arrive at the same solution as we did if we were to factor.